Java loops 2. So the problem, we use the integers a, b, and n to create the following series: a plus 2 to the 0 power times b, and then in the next iteration we have a plus 2 to the 0th power plus times b plus 2 to the first times b. So yeah, we're given q queries in the form of a, b, and n. For each query, print the series corresponding to the given a, b, and n values on a single line of n separate integers. Alright, so let's look at the explanation. Oh, before we do that, I'll create some code for you guys so you can start thinking about it. So we're gonna have a method named query. It's gonna take an a integer, a b integer, and a c integer, n integer, right? A is what is A? A is gonna be the first number in each step. So if you take a look at our explanation, we have a equal to 0, b is equal to n, b is equal to 2, and n is equal to 10. So you see that a comes up as the first number in each step, and only the first number. It doesn't appear anywhere else within our steps, or in our algorithms is a better term. Anyway, so yep, let's create our query method. I don't know if it's a good title for it, but I don't know. Just wanted. I don't know. I didn't know what else to name it, so I was just like query. Yeah. So here we're gonna create our algorithm. So if you're not too familiar with like how methods work, or how to build them, how to create them, you might want to watch a YouTube video on that. But you don't actually need to know what any of this stuff is. The main important stuff is within this algorithm. Alright, so yeah, so what are we going to do? We're going to create an integer. We're going to set it to 0. I'm going to call it number. So number is going to store our end result. So you see on step 0 we have the number 2, and then the sample output we also have the number 2, and then in step 1 we have 6 as our result of step 1, and then in our output we have the number 6. Alright, so and then in step 2 our result was 14, and that came out in our output. Alright, very easy. So we're gonna set our for loop to 1, and it's gonna keep going so long as it is less than or equal to n. Alright, and so why am I setting my iterator I to 1? It'll become more apparent a little bit later. Alright, so number here, what we're gonna do is we're gonna do a plus 1 times b. So why am I doing that? Okay, well, if you scroll up and then look at the equation, we see that a plus 2 to the 0 power times b is always the first like step in the algorithm. So on the first iteration we have a plus 2 to the 0 power times b, and then in the second iteration we would have a plus 2 to the 0 times b plus 2 to the first times b. On the third iteration, what we would have is a plus 2 to the 0 power times b. Again, it came up again. Plus 2 to the first times b plus 2 to the second times b. Alright? So right here we're just simply taking care of this first part of the equation. If you take a look at explanation 2, we see at step 0 we do 5 plus 1 times 3, b 3 is equal to b, b is equal to 3, and a is equal to 5, 5 is equal to 8, and then in the second step we have 5 plus 1 times 3, and it just continues on. Okay, so now this is our outer loop. Now we're going to create our inner loop. Our inner loop, we're going to have a variable j as our iterator, and we're going to set that to 1 as well. And we're going to say that so long as j is less than n, we're going to continue our iteration. Okay, here we're going to have number plus equal math.pow. This is how we're going to get our exponent times b. Yep. Okay, and then what we're going to do is here we're going to print out our results. So we're going to print out number. Alright. Alright, okay, so let me explain this part now, this part of the code. So what this is doing right here, we're doing so say we're using explanation 1, right? We have 1 times 2, which is no, let's look at step 1, sorry. At step 1 we would have 2 times 2. So how do we get this 2 right here? We did 2 to the first power times 2, okay? And b is equal to 2, right? And then if we look on our next step, we have 2 to the first power times 2 plus. So you see I do num plus equal. So we're adding the result right here. We're adding the result of and our third step, 2 times 2 plus 4 times 2. Okay, and again we're getting the 2 and the 4 here by using our exponents. Okay, if we look at step 3, we have 2, 4, 8. Again, we're using our exponents. And then for step 4, we have 2, 4, 8, 16. Okay, that's how we got that. Now onto the reason why I'm using why I'm starting at index 1. Okay, so if we start off not at index 1, at we're setting our iterator to 1, because on our first iteration we're going to complete this, right? And then we're not going to go into the for loop, to the inner for loop. Okay, so we're going to complete this step. We're going to complete step 0. It's going to print out the number, and then on our next iteration we will go into the for loop. Okay, and then here I'm just gonna, at the very end of it, I'm going to create a space, because if you look at the sample output, there's a space, right? This is one query that came in, and this is the next query. Okay, and if I run it, it should work. Might have maybe an error or two. What went wrong here? Oh, well, we have really big numbers here. That's what went wrong. Let's see where was the mistake on that. Number a plus 1 times b. Oh, yeah, this is why. You have to switch n to I. Yep. Okay, so let me explain that. Why is j going to keep on going so long as it is less than I? So let's use step explanation 2, step 2 as an example. Here we have I is equal to what? In our case, I here would be equal to 2. So we only perform 2 operations here. And then when we go to step 3, we perform 3 operations. This is 1, this is 1, and then this is another one. Okay? So yeah, that's how that would work. So when I is equal to Um, when I is equal to 2, we perform 2 operations. Okay. And all our test cases